Welcome to Peoples and Things, a podcast about human life with technology. I'm Lee Vinsel, an assistant professor of science, technology, and society at Virginia Tech. My guest is Daniel Armanios, an assistant professor of engineering and public policy at Carnegie Mellon University. Today, we'll be doing something a little different than most episodes. Instead of homing in on a single work, we'll be talking about several articles that Daniel's written and how they fit into a larger research project that examines the relationship between engineering, infrastructure, and inequalities around race, class, and gender. Daniel, thanks so much for taking the time to talk to me today.
No, thanks so much, Lee. I'm really looking forward to it.
So I want to give listeners a really kind of concrete example of the kinds of topics you've been exploring and in terms of method, how you've been looking at things. So I thought, could you give us an overview of what you and your co-author, Samuel Jones, look at and found in your article, methodological framework and feasibility study to assess social equity impacts for the built environment?
Yeah, sure. So it's nice to give context to this paper. So what we're trying to do here is there's been a lot of discussion around issues of equity. How do we make sure that we try to address them in ways going forward that would help, in engineering decision making around infrastructure and the like. And one of the things we found is that there's a lot of literature, or increasingly so, saying there are these biases, saying that there's these discrepancies. But the challenge has been, how then, when an engineer asks, great, I know these are happening, how can I address them? What kind of methods could we use? So what we tried to do in this paper is say, can we think of methodological ways to address these issues? And then, based on applying that method, what do we discover in how we applied it to the bridge system of the Commonwealth of Pennsylvania? So for bridge systems, what we found, there's kind of two issues. One is making sure you're as sharp as possible of the zone of what we call the zone of treatment of the bridge. So when I have a bridge, it's on a network of a transportation system. How do I make sure that we capture that in a conservative way so that we can ascertain the expanse or where the bridge is affecting a community? And, admittedly, we did this in a conservative way because we wanted to have this such that whatever results we find, it's likely underestimating the effect than overestimating it, so that we're trying to be as conservative to the analysis as possible. So what we did there was we actually mapped the bridges onto the transportation network. And then we looked distances away from the bridge and asked ourselves, at what point does the number of census tracts that are touching that bridge all of a sudden just blow up? And what we found it's pretty remarkable how distance sensitive it is. Around maybe 500 meters from the bridge, that's when you start seeing the tracks blow up. So we cut it off at like 500 meters to the bridge. So essentially, the impacts we're finding are within tracks that border a bridge within 500 meters. So we're talking pretty small distances.
Yep.
Then the second issue is, how do you make sure you're comparing apples to apples, right? Every census tract has different water areas, different land needs, different elevations alike. So we matched on a series of criteria so that the only real difference between the bridges, the tracks with these bridges, are these different demographics or different equity measures that we were interested in. Mm-hmm. We looked at income, we looked at race, we looked at education, the like. And once we did that, what we found is there's kind of two ways you can think of infrastructure. One is, does infrastructure get cited in certain places differently than others?
Yeah.
And then the second question can be, well, what happens once the bridge is placed? Is something happen to that community after? Mm-hmm. And some in sociology and economics and others would say, is this a difference between a selection effect versus a treatment effect? Mm-hmm. And what we found is a lot of the statistical associations we found were overwhelmingly around selection, where these bridges are sited, not anything that really happened after. And the kind of sad punchline is that we found that fewer bridges are statistically associated with racially diverse populations. So the more Hispanic, more African-American, Black, more non-white, more foreign-born, the more statistically associated you are with fewer bridges. Huh. So you have less bridges. And then to add more to the sadness of this is that even if you get a bridge, it's more likely to be restrictive. So restrictive means anywhere between 14 to 16 feet or lower, which implies, to give this more kind of meaning, certain buses, certain trucks cannot go through those kind of bridges, go underneath. Yep. And what we found is also, if you're not with foreign born, but with percent Hispanic, percent African American Black, percent non-white, those percentages increase, you're statistically associated with a more restrictive bridge. So the punchline is you're associated with fewer bridges, and even if you get them, you're associated with less bridges, with more restrictive bridges. And so I think the transport has some implications to the Commonwealth of Pennsylvania, but I think what I'm more excited about with this paper is the ability to replicate this method for bridge systems in any other context where you may have different equity measures that matter, different things that change the outcomes.
That's nice, man. Mm-hmm. And you've also looked at the impacts of some of these disparities. So you have a forthcoming paper on bridges and entrepreneurship, right? Yeah. Where you think about what are the ramifications of access to bridges for different racial and economic groups. So what do you find in that paper?
Yeah, so this is a paper that was led by Sunasir Duda at the University of Minnesota and in collaboration with a former PhD student, Jason Desai. And what we were trying to do there is, once you read the paper that Sam led and that we just discussed, you start asking, okay, well, why does this matter, right? Okay, so you have these disparities. Perhaps there's reasons for these disparities because of different needs or whatnot. So why does this matter? And what we discover in that paper is even as little as one additional bridge in a city can increase founding rates by almost 20%.
This is the founding of new firms.
Founding of new firms. And then we said, okay, well, to make this even more kind of consequential for economics, economic systems, we know that high-tech entrepreneurship is often argued as a real avenue for growth. So we went and scraped Crunchbase data, and we then showed that also has an impact on more high-tech founding, about, if I recall correctly, about 9 to 10% increase. But what's even more interesting, because our argument is bridges allow for new forms of connectivity. So if that's true, then the quality and kinds of high-tech ventures should also be greater, also be more novel and more innovative. And sure enough, we found more early investors participate in the firms. These firms tend to span more industries, and they tend to recombine different knowledge sources. And then to harken back to old school Jane Jacobs and coming back to the necessity of sidewalks for cities, it turns out that a key moderating factor is the sidewalk length around the bridge. And so the analogy I kind of give is like, if you go to a gym, you end up, you go at a specific time always, and you end up seeing the kind of same people. And eventually at some point you're like, I'm keep seeing this person. It's kind of odd. I don't know them. Let me strike a conversation. So you could kind of think of the same thing with a bridge. If I run on a bridge, have a run on a pathway, and I go on my run or something, and I see the same person, I see you all the time on the bridge. Eventually at some point I'll be like, Lee, I always see you on this bridge. What are you up to? What's your name? Such, and you shoot up a conversation. And from that, all sorts of serendipitized ideas can emerge. And so the implication is that if you take this finding, which is physical connectivity still matters even for high tech innovation. And by the way, we did this across different industries. We find this in biotech. We find this in computer and IT based startups. If you take that with what we found with Sam, at least in the Commonwealth of Pennsylvania, which is that not everyone gets these new bridges, then it has some really deep implications potentially for the American dream. If the American dream is for you to come and make it and improve, that some of this at least potentially could be adjudicated from literally the sidewalks of bridges and their connectivity. Yeah. And so you start realizing how upstream in a process this could matter. And I think that's the kind of thing that I think now that we're seeing this, besides the methods to do this, you start seeing some real different angles you would think about some of these historical issues when you start thinking of literally the bricks and mortars that are kind of driving where we go and who we see.
Yeah. I want to talk about more about impacts for
Hmm.
different groups with infrastructure. But first, I thought we might go back and talk about how you got into this. So
Hmm.
I saw that you have a PhD in management science and engineering from
Hmm.
Stanford. How did you get into studying infrastructure and inequality? Was it part of your original PhD research, or is
Hmm.
this something you kind of stumbled onto later?
Yeah, I would let we always try to like retrospectively sense make like, oh, it was this amazing journey that was completely curated. And I can
Yeah.
honestly tell you, yeah, like and it's part of like our mantra, so to speak, in some sense.
Right.
This was definitely kind of stumbled on this as an additional line of inquiry from what I was initially doing. So what I initially studied was scientific infrastructure. What I mean by that is, you have some great innovation happening in a national lab, in a university, and you're trying to figure out how do I get that to entrepreneurs and work with government to actually get that technology into a market. And what I had been focusing on initially is trying to understand the different roles public organizations play in helping that process. How do you get
Hmm.
innovations out to the market? And my focus, ironically, not ironically, but kind of weirdly enough, was China. So I spent a lot of time studying the internal practices in China. And what I discovered was the same kind of what I call institutional infrastructure that was driving how scientific infrastructure operates. And just for all of us in our audience to be clear, what I mean by institutional infrastructure is just a fancy way of saying how do different organizations coordinate to underpin the functioning of a system you have. And in this case, we're talking about an innovation system.
Hmm.
And when I started looking at other kinds of systems, I started reading really old school Langdon Winter work about artifacts as politics. And I started thinking, man, this infrastructure also affects literally physical infrastructure. It's not just
Yeah.
science, pragmatically speaking, with a bridge system, you have a bridge authority in the city. They got to coordinate with the state. The state has priorities of what they want to maintain or replace in bridges. The city has a different one. How do they coordinate that? How do you even get, in Pittsburgh, we have more bridges than any other
Yeah.
city. How do you coordinate all the inspections? How do you coordinate all
Yeah.
the structural assessments? I mean, this is not trivial. And so
Mhm.
what kind of brought that alive to me is that even though you have these static pieces of physical structures, these physical infrastructures, it's a whole dynamic array of institutions that have to maintain that. And so
Yeah.
I started thinking maybe I can take some of those ideas and transport them in more engineering settings. And I think the bigger picture, and this has been the fortune of the department I'm in a school of engineering, and as an organizational theorist, most end up in business schools, and they tend
Hmm.
to study markets and business. And I think that's been a real fortune for me because it's allowed me to bring in organizational theory into engineering systems that have not been typically an area of inquiry in organizational theory. And in
Hmm.
my opinion, to its loss, because there is such a wider array of non-market factors we could be really speaking to and assisting policymakers that we're just not involved with because of the nature of where most of us end up in
That's
terms
really
of our
interesting.
career. And so speaking of selection or treatment, this seems to me to be a selection issue in
Yeah.
some sense. And so that's been something that's I've been really kind of interested about and thinking, and it just happened to be taking a conceptual idea I had in one area and bringing it into the study of this area.
That's cool, man.
Yeah.
The idea that infrastructure, power, and inequality are tied together has been around for a long time. And I was actually going to bring up, that famous 1980 essay by Langdon Winter, "Do Artifacts Have Politics?" Right?
Mm-hmm.
So he, in that article, famous to lots of academics, he
Mm-hmm.
argues that the city planner, Robert Moses, designed restrictive bridges on a Long Island Parkway to keep buses off of it because poor people, and especially poor Black people, used buses, right? So he
Mm-hmm.
was like creating racist bridges.
Mm-hmm.
And I think that idea has been around for a long time, but part of what I've seen you up to is that you're trying to find new empirical ways and new methods for really, examining this question and maybe even testing it in a sense. Is that
Mm-hmm.
fair?
That's absolutely fair. I mean, that's the inspiration with the paper, not just that I did with Sam, but also Jason, the other paper we did on bridges as institutional relics and looking at how the social systems that build a bridge, the bridge stays well after that system changes. And the inspiration was, the debates that came after the Winter Peace. Some were arguing, well, this is anecdotal or this is not true. And there's some technical reasons for this and all sorts of things. And I said, why can't we let's just study it? Let's just see. And it turns out the National Bridge Inventory has the underclearance heights of any bridge that's longer than 10 feet in the United States. And so you say, okay, let's at least up till 2012. So we had this massive data set and we said, well, let's just see it. And sure enough, we find that New York has systematically lower clearances than even cities that had a very similar infrastructure profile, similar big personality urban planners. Like in the case, we compared it to Boston and Robert Callahan. And you see that distinction. And so we can't necessarily argue the mechanisms of winter, that there's a discriminatory intent, but we definitely see there's potentially some kind of segregation or divide. And so that's a very good point. And I think that's the benefit of, I would say, computational social science in general. I think where it's been really useful is taking these first principle ideas that people have and think, well, how expansive is it? How general is this? Is this happening? And I've seen this with a lot of things. Like there's some other work looking at, for example, confirmation bias that we know in psychology that people tend to read what they're only doing. And people research that on every log of Microsoft Internet Explorer and do it on a bigger scale. So I think that is definitely a fair thing to say. I think I'm adding some novelty in terms of the organizations involved in it and how you can theorize on them. But definitely the impetus was, I'm just curious if this happens on a bigger scale.
Right.
And see. No, agreed.
Yeah. I also some of your earlier work looked at these same kinds of issues around gender and electricity in India. So why don't you tell us a bit about that work and what you found?
Yeah, sure. I want to start with how this is the joy of being, an academic and you giving lectures and having very inquisitive students. So after one of my lectures at a place, one of the students came up to me and said, I wonder if this is happening around gender, and I'm interested in Indian energy. And that turned out to be Maytal Rosenberg, who's the first author in that paper. She was an undergrad when we did this. So I'm not sure how many undergrads have been first author in a Nature publication, in this case, Nature Sustainability, but just want to give her some props for that because it just came out of a question and then we just kind of ran with it. What we were trying to do there was we looked at the current literature and how people tried to understand more generally advancements in SDG goals, so sustainable development goals. And there's a series of these goals where they're trying to address different issues like access to energy, access to health, gender inequality, et cetera, or gender equality, et cetera. And what we found, what was difficult was that people were typically analyzing these goals in isolation. So they would say, okay, how are we dealing with gender equality? Let's focus just on that. And then we'll see, are we getting an up or down? And it struck us that there's a lot of interdependencies between these goals. As I push one up, it's not necessarily clear I push another one up. And also the linkages tend to be focused predominantly on different infrastructure goals, not the society to infrastructure goals. So when we started pulling that thread, we said, well, let's look at two of them. We have gender equality and energy access. And the tacit assumption was if I increase energy access, that should actually address gender equality because those who need energy access more tend to be those of a female gender. And for the stereotypical reasons provided is that they're the ones in a lot of societies, better or for worse, are often responsible for the family caregiving duties, etc. And if you have
domestic
access
labor, right?
Exactly. Yeah. And if they have access to energy, it frees up time to do other things.
Yep.
And so when we looked at that further, there was an issue with the measure. So speaking of, bringing it back to how to empiricize this, they measure access to whether or not you have a grid connection. But ultimately, if you want to make an argument about equality or equity in terms of gender, you need to know usage, not access. So you need to know who is using what in the household.
Yep.
So Maytal had a study abroad opportunity to go to India to do this work. She set up a survey that I helped her kind of calibrate to ask who uses what in the household, different members. And we asked it mainly to female respondents. But when males were in the room, they tended to, there was no disagreement.
Yeah, right.
The women tended to understand what was going on. The females in the survey had tended to know what's going on. And so when we map that out, go ahead.
Can you give me a sense of like what kind of items were on the survey? What are you asking about?
Yeah. So we asked them, for example, who uses mobile phones in the house, or do you access mobile phones? How many light bulbs do you have in the house? Who uses them? TVs, the like.
Yep.
And what we found was we codified who was using what in the house, and it turns that most houses had access mainly to appliances that the male genders in the household preferred, right? And so we asked it two ways. We asked, what do you have in the household, which is the access, and then who uses it?
Yep.
And it was overwhelmingly the male-oriented appliances or male-preferred appliances. And so some would ask, well, maybe it's because the kinds of things that one gender needs are different, require more electricity. Like maybe I need a sewing machine or a grinder, an oven, and that uses more energy. When we restricted it just to fans and light bulbs. So fans and light bulbs are ubiquitous. Most households had more than one or two. Mm-hmm. And when we asked them where they placed those light bulbs and fans, they were overwhelmingly not in the kitchen where the females would use it. They could have literally taken it out, put it in the kitchen, and it would immediately have some equity implication. Mm-hmm. And yet most houses had numerous ones, and only, maybe if I can recall correctly off the top of my head, 15% or so maximum even had a light in the kitchen. Mm-hmm. I mean, so we saw this distinction. So then we said, okay, it seems very clear there's this distinction. And then we try to say, why is this happening? So we asked other questions like, how much do you feel you have control over what you can do in your day-to-day affairs? And how much time do you have for leisure and so on? So we asked these kind of more perceptual questions. And there was definitely notions from female respondents that they get access to more information or leisure, but very few of them felt they actually get to do what they want. I think something like, if I recall the numbers off the top of my head, 27% of women, after they got electricity, felt they get choice over what they want to do. 27%. Mm-hmm. And because we did ethnographic interviewing, which is not just looking at the interviewing, but seeing all the nonverbal cues that happen, the setting, there was literally instances where the interviewer stopped once the male respondent came into the house. That is how palpable the power dynamics were there. Yeah. And so even though you have this electricity, the power dynamics clearly in the household was driving who was using what in the house. And so that became a testable proposition from our qualitative work. And so we tested it on a bigger survey. And we said, if this is true, we should see light bulbs tend to be reported more by male genders. And that division happens even more with the kitchen. And then we said, if this is true, it's about power dynamics. Then if we have female-led households, either the female's widowed or the head of the household, then we shouldn't see this effect. And sure enough, we didn't see the effect in this way. And so the implication was you can't make sure quality happens with energy access unless you look at usage. Yeah. And usage seems to be influenced by power dynamics.
Right.
And the implication from that also comes more generally is if we want to see growth in SDG goals, we can't look at them just in isolation. We need to understand their interdependencies for us to make sure that we're making advancements in those goals.
Yeah. I mean, it reminds me just kind of like it's almost a truism in the field of science and technology studies that we tend to kind of fetishize technological solutions to problems, right? But these technologies are being put in social systems that have all these issues around power and inequality and such. And without addressing those social problems, you're not really you're just not touching it, right?
I really love this point, Lee. And this is something I think we share in also your line of work as well with your new book, The Innovation Delusion, and others. I think there's a lot of discussion around artificial intelligence, additive manufacturing, these bigger kind of technology that are new, not taken for granted. And you immediately think, yes, there's biases. And surely there are. But my argument, and I think maybe something perhaps we share, is the legacy technologies, in my opinion, are much more pernicious in how they generate these equity issues, because they're so taken for granted as, oh, it must be based on some technical analysis, or it's so obvious how to do that, that you never think of all the kind of social contentions, conflict, power dynamics that get involved in that. And I think it's become, and that's why it's also hard methodologically to test, because these are so taken for granted that it's not necessarily immediate to mind that I would be thinking about that. And so that's, I think, where in my opinion, the frontier is not on the cutting edge, it's on the trailing edge. I think that's where it really, for these kind of issues, that's the frontier. And I think once we solve those or address those, then when new issues arise, I think we'll be better equipped to handle them, especially their longevity. And we're not there yet by any means, but I think hopefully we can get there.
Yeah. I had a thought and it went. That's what happens at this time of the day. I feel like this is going to be a theme. This happened to be in one of my last interviews, so that's going to happen. It's going to be part of the show.
Yeah, I had a thought.
I know what I wanted to say. What is so? I just want to be clear for myself and for everybody else. Like, what is legacy system? What do legacy system means in your community? Just because I think it means different things in different places.
Yeah. So when I think of a legacy technology, I think of a technology whose kind of technological needs are kind of well known.
Yeah.
So if you're thinking of like a bridge, think of roads, think of water systems to some degree.
Okay.
Those are things where we have a clear kind of technical understanding. There's no kind of, it's not as debated. Yeah. I mean, every technology, mind you, has debates, but they're not as front of mind and salient, those debates, as you would think for maybe a novel technology. And then the reason I like to use technology in this way is I think of technology in a more kind of general conceptual way in the following sense. I think of it more like the underlying knowledge that's undergirding it, not just the physical embodiment. So, for example, just as an analogy, this computer is a technology, right?
Yeah.
But I don't necessarily understand the knowledge underneath it. I'm using this computer. Do I understand how the semiconductors work in this or not? Not necessarily, right? And so this is like, I like to detach a little bit the knowledge system and the technology, because that also, by the way, allows us to also look at some very innovative things that happen in more global South contexts as technology, right? Because, for example, there's some tremendous labor-intensive waste management systems that don't use any physical embodiments that seem any kind of cutting edge, but the knowledge systems and how they've developed it are quite deep and profound, and I would consider that a technology. And so to bring it back, legacy technology, I look at it as a system that has had an extensive technology kind of trajectory such that the debates in that place are not as front of mind, are still not up for grabs as they are in other places.
Right on. I like that a lot. I think coming back to the U.S. for a bit, I think that we know about, I mean, there's a long history of kind of racist infrastructure, right? And we can think about I was listening to a talk of yours earlier. You were talking about the Hill District in Pittsburgh, which was a Black neighborhood that was, because it was blight in quotation marks, and it was, it was redevelopment. It was wiped off the face of the planet. They built a hockey rink there and things. And, I think lots of parts of the interstate highway system in the 50s and 60s were basically built through Black neighborhoods. I don't know the story of the Cross Bronx Expressway, but you mentioned it as an example, I think. And so how does that history, I think, which we know, like basically people were selecting, poor and usually often racial minority neighborhoods as kind of zones for this, connect with your work? Is there a deep connection with bridges and stuff there?
Yeah, I mean, so definitely the impetus for this research was because we know these legacies and we know these historical, really rich stories that really analyzed rigorously what happened in these areas. And so in some sense, you could argue my way is to provide even more scale to that story and give those stories more life and reinforcement in some sense. I think the other sense is that how it also implies, and we see this also in some of the work that we did recently, Sam's, and also the one I did with Sunasir and Jason, is that once you've built those technologies, they have tremendous lock-in effects in the following sense. I'll give you a really kind of very mundane but kind of example that happened to be in our case with Sunasir and Jason. One of the cities that seemed to have the strongest effects of new bridges was Louisville, Kentucky. Mm-hmm. And they created these two bridges. One is the Lincoln Bridge, and the other one's I think the Lewis and Clark Bridge. I can't remember. There was two bridges. It's the the Ohio River Bridges Project in general. And what was interesting, there was a subtle point they brought up that kind of done in passing, but I looked at some documentaries and other evidence. And one of the things that was interesting is the initial intention of the bridge was that they had this massive spaghetti junction, and engineering systems over time have recognized that this is not necessarily the best way to do infrastructure. And so one of the things they wanted to do was unravel that system and kind of put it together. And they gave up because what happened was once that system was built, what happens? Housing starts getting built next to it. Roads start getting built next to it. And it turned out to actually remove that footprint, you have to displace all these other proximate infrastructures that lock it in. And they just gave up. And so one of the things that's kind of sad, and this is why legacy technologies are so crucial, in my opinion, to understand, is that even if you recognize they're a problem, to remediate them is really difficult because other infrastructure systems get placed accordingly.
Yeah.
And so one of the implications that means is that twofold. One is we need to be mindful now of any incursions that continue in those areas because they will last beyond that time. And secondly, is that those issues often are not going to be front of mind to people because they don't necessarily see all these issues. And so, for example, with the Hill as an example, it wasn't just African Americans that were impacted. It was a massive, important area for immigrants. Anyone who was first coming to the city came there.
Interesting.
And so, with the civic redevelopment project, it removed 80 city blocks, 100 acres. Yeah. This was 8,000 residents, about 1/5 of the population. And so, the vibrancy gets lost in that. And what's worrisome is that it's not clear unless there's a really deep structural change in the urban landscape, whether you can get that back. And so one of the things that come out of this in terms of my research is I'm trying to make this salient to people in a way that's scaled beyond these important kind of historical narratives analysis so that it can heighten the impact and heighten the salience. Yeah. And that's kind of where I see some of the work is. And in fact, a lot of the inspiration I have, as you mentioned with Langdon Winter's pieces, I see these answers. I'm like wondering, this seems very logical, very plausible argumentation. And I think it has truth. Let's test it. Is it true? Where is it true? And the other thing I will say that I haven't touched on that's I think is also important about the kind of rich context of these narratives is that also the way the restrictions work or the way the segregation and bias works or discrimination works is so different based on the local cultures. So I remember having a chat with a colleague of mine, and I was talking about this work and the restrictions and the underclearance bridges. And they mentioned to me that it almost operated very different in what they said in the Ninth Ward of New Orleans, where they said, actually the aim is to make the bridges as high as possible. So all the trucks, all the traffic, all the noise that you want to deal with, all go through those areas. And so why I think these stories are also consequential is they really important to get context and what I call some in the methods space would call construct validity, to be really sure that you're measuring what you say you're measuring. And why does that matter is if I took that same analysis I did in New York, where we had anecdotal evidence and measures to say that restriction is based on lowering bridges, and I apply that to a context like New Orleans or elsewhere, where that actually means something very different, all of a sudden you have an analysis that's flawed because you haven't really thought about what does that mean contextually. And so I think these stories are also sources of inspiration for my work. And I use stories, by the way, I use stories here in an empirical sense, because I think some people will say stories and so forth to kind of denigrate that kind of work. And that's not what I use it here. I use it as it's empirical in its own right. It's just a different kind of data. And I like to use stories because you're getting a lot more rich understanding of it. And I use that in a balanced, equal way with statistics, not as a way to say, oh, that's just a story and anecdote that we don't care about. So I want to be clear to our audience that I treat them, statistics and what I call rich storytelling, rich revelation of qualitative data, on equal footing. They both have their use and importance.
Yeah. Amen, man. I like that. I mean, that's part of what I've been seeing is that, I teach classes on infrastructure and maintenance and all these topics. I think there's a lot of really good ethnography on infrastructure going on right now. And, like my friend Alex Wellerstein likes to say that ethnography just means deep hanging out, right? It's just like going somewhere and chilling out for a year, not really chilling, watching people do what they're doing for a year. And that's very valuable. There's a lot we can learn from that kind of research. And it's not, I think, but you're doing something different. I think these two things play together, right? And you're also showing us things at a different scale.
Right.
So I think that's, I think that these two things are very important together.
Agreed.
Yeah. I liked, I was moved by a story that you told in one of the talks I watched about Raquel Nelson, a woman in Atlanta, Georgia. And I thought it was really gave, a hard-hitting and very specific story about kind of how access to infrastructure can affect people's lives. So can you tell us about her story?
Yeah, sure. So one of the things it's, with statistics, you have the other problem that you don't have with stories, which is, how do I give life to this just like abstract data point? Like, okay, great. You have this dot somewhere. Explain it to me. And I think why people bristle at that too is there's no human side to it. So I tried to show in this story, just as a way to give the punch on the beginning, it shows really the human toll and price that happens with decisions and biases that happen in infrastructure. So Raquel Nelson's story is that she's a single mother of 3. And put yourself in her shoes for a moment. You don't have a car, so you're taking a bus. You maybe even more than one bus ride. You then come home, and your home is Pleasantdale Road in Atlanta, Georgia. You stop at the bus stop, and literally across the street is where home is. But in your street, you don't have a pedestrian crosswalk. You don't have lighting. So you can't safely cross, and it's a busy intersection. So what you have to do is go down Pleasantdale Road to the nearest marked intersection, cross, and go back up. And so what should be a journey of a few meters ends up becoming half a mile.
Jesus.
And so what ended up happening really tragically in this case is that her son is tired, was antsy, wants to get home. He's holding her. He lets go, runs into the middle of the intersection and gets hit by a drunk driver and dies. And on one hand, if you just look at that story in the minute, you think, oh my gosh, what a sad circumstance, etc. But then when you blow this up and see, could there have been some easily preventable ways, like having marked crosswalks, having lighted areas, and seeing, does everybody have them? You get a story that's sadly not just limited to Atlanta or not limited to Raquel Nelson. And by the way, before I continue further, why this story got such national press is what was horrid about the case, in my opinion, is that she was then charged with negligent homicide because of the situation. And they said it's because of infrastructure. And it even showed out legally that even if she used the crosswalk area appropriately, it wasn't technically marked. And so you couldn't actually have legally crossed even at the lighted way. And so it became a huge thing. They had the cases dropped, but she still had to pay some kind of fees or other things. And so, the reason that got national attention was because of how this was handled in the case. But why I thought this was an important case for the perspective of engineering is if we go back to where I was going previously, which is if you blow up this case beyond Atlanta and beyond Raquel Nelson, and you look at low-income communities, middle and high, only 51% of streets in low-income communities have street sidewalk lighting, literally lighting to show your way to where you're going. And only 49%, at least of the data that I've seen most recently, had even a sidewalk versus, by the way, 80% plus in high-income areas. And so what you start realizing is the access to sidewalks, the safety it provides, the lighting is a privilege, of economics. And so when you start seeing that, you start having to ask yourself, I was trained as an engineer. Even though I'm, my background and theoretically is in organizational sociology, my degrees are in engineering. You start asking yourself, even though the engineer is clearly very distant to the locus of that issue, how complicit, how kind of responsible are we for ensuring infrastructure is more equitably distributed? Yes, we're not there at the moment trying to harm Raquel Nelson, but we have to start asking ourselves, when we design our urban development plans, when we do our structural assessments, are we considering people like Raquel Nelson in those analyses? Are we considering the fact that there is not this even distribution, there's this skew distribution? As a means of another example to even bring this further, we also see this in standards testing with engineering. So it turns out that the standard for a female crash test dummy, so the ones that are tested for crash worthiness of a car, the female crash test dummy up till very recently was 110 pounds, 5'1". The average woman is 5'4", 170 pounds. Okay. By the way, these female crash test dummies weren't even used until 2003. So the assumption was women, besides the fact that you have a very stereotypical view of a female body,
right.
Besides the fact that, and also the fact that you had one dummy before then, which you're assuming that biomechanically female gender have similar kind of resistance or reaction to a crash than a male is beyond the point. What's the implication of that? A study was conducted in 2014, and I believe near you at either University of Virginia or Virginia Tech. I can't remember.
It would be us. It'd be Tech. Yep.
Yeah, Virginia Tech. They actually found that 73%, that females were 73% more likely to die or get seriously injured in a crash versus males. And this was attributed in part, at least, it had to be, at least in my opinion, but obviously we can't make this connection directly. There had to be the fact that the crash test dummies were not built to spec for a typical female body. And so why I like these examples, they really show human life is at consequence. When you start looking inside this data and start seeing the ramifications, even though you're upstream as an engineer and the ramifications are more downstream. So part of what I think is my hope with my work and my teaching is to help connect that more closely to an engineer. This is what happens downstream when this happens. How can we solve it? How can we address it here now so that we can prevent or preclude those issues later on?
Right on, man. Why don't we talk about your life as a teacher for a second? Because I know you're teaching a course on engineering and social justice this semester, right? So what do you cover in that?
So what I try to do is and I have to say, because this is important, and I've noticed this is, and I don't want to give too much attribution, in my opinion, the pioneers of engineering and social justice, especially pedagogically and even research-wise, they have two mothers. So Carolyn Bailey, who's at the University of San Diego, and Donna Riley, who's department chair in engineering education at Purdue. And so I do this importantly because the attribution, I find this often typically in fields I even discuss, where all of a sudden once a few of a background start into that, then it's them. It was not me. So there's definitely giant shoulders to be on. The approach I've taken and what I've tried to do is covering is that, because I'm trained more on the sociological side, I wanted to give kind of more, I didn't want to use as many thought experiments just because they're important, but they're just not my training. And they're not, I felt it was harder for me to give life to those kind of things. So the way I've done the course is, in the first part, I ask students, what is social justice for them? What are the kinds of fights you want to take on? What are the kinds of issues you'll have versus if you want to change the system or work within it? What are the pros and cons of each? Then we start deconstructing and really getting into the engineering legacy. So one of the things I do with them is I have them actually take a job survey and I ask them, what do you prefer in a job? And of course, the students themselves say, I prefer meaningful work and having, feeling like I'm rewarded and so forth. And I tell them, what do you think a blue collar worker wants? And almost always, I've done this in multiple universities. Almost always, they say money and job security. Yeah. And then what I do is I tell them, and the reason I do this is that I then tell them I then take the general social survey and I take the actual findings that you ask from general, and you see that there's really no difference between what blue collar workers want, what white collar workers want, etc. And I do this because I then have them read Frederick Taylor's original Scientific Management. So I have them actually look and read, and what were the assumptions that Frederick Taylor does? I, the engineer, know how you should work, and all you care about is job security and money, and so that's what you should care about. And it just, why I have them do the survey today is just to show how amazingly, how much longevity that assumption still has in engineering. I mean, this was in 1911, right? 1950.
Taylor's the father of scientific management.
Yes,
for
thank
those
you.
Who don't know.
Yeah.
So when we think of like engineers coming and improving efficiencies in workplaces, he's kind of the one who gets that kick started.
Exactly. And he had influence, I believe, as one of the founders of American Society of Mechanical Engineers and other things like this. So he has a legacy, and why I wanted to give that, because when the students read that, I have them read as required. They think, that's, of course, I don't think like that's out there. And it's still going on, right? Yeah. And it just kind of, it jolts them. And so you realize how much this is kind of permeates. And so I have them kind of deconstruct the legacy that way. We look at, then we've been looking at, the next thing we did is I then looked at how social movements happen within engineering. I have them read The Revolt of the Engineers by Layton, look at like how civil engineers generate a social movement, and, through Newell and others that changed, because initially ASCE, American Society of Civil Engineers, for our audience, was the first kind of big organization around engineering, and then all the other professions came. And it was interesting to see how social movements arose in that, and some of the beneficial but also negative consequences of that in terms of ingratiating some of these ideas. And I just have them unpack our own legacy as engineers. What are we trying to accomplish? What have we tried to do? And then we go through different systems. We've been going through transportation. We're going to go through energy, AI, healthcare, and where we have been complicit in some of the issues. And then at the end, I say, great. So I've told you all of these biases and issues. Can we then do some methods to think about how we can identify these issues or potentially solve them? And there's some really other cutting edge stuff that's going on. Like there's some interesting work happening by some engineers like Destiny Knock in our university. It's looking at multi-criterion decision making, where they say if you want to incorporate equity, how does that balance with other kind of stakeholder decisions so that you can actually directly problematize it in analyses? Besides my work on mixed methods, and then to try to say, look, I know I've given you a lot of bias, a lot we have to overcome, but there are methods we can use to try to start identifying this more rigorously, trying to think of solutions so that we're not just talking about how bad things are, but how we can solve them. So that's kind of how that class goes. It's been really rewarding. I think I'm learning more from the students than I think they're getting from me. It's kind of
so cool
teaching. It's been amazing. Really enjoy it.
So where are you going to take your work next, especially when it comes to this legacy technology issues? Where are you going, man?
Yeah, so I'm really excited about a current grant we have, which is about more on the solutions end now. I am working with some colleagues, Casey Austin out of UT Austin. We're thinking about seeing, can we use local indigenous knowledge systems to rethink infrastructure maintenance of more modern systems. So our context here is one of the issues in Alaska is to try to do, especially in that extreme climate, is trying to train water operators. But in a lot of these rural areas, these are coming from Native Alaskan communities, and these communities have a very indigenous, different knowledge system, different view of nature. And we're trying to say, and then they brought in this Western infrastructure almost as a way to assimilate these groups. And it's
had like water sanitation systems.
Okay. Yeah. Yep. And so we're saying you have this challenge now, which is you have an indigenous community system, and you've brought in this like foreign technology, And
Yeah.
what the story has been almost unequivocally is that it's disrupted and really changed for the worse these local communities.
Interesting.
And so now the question is, what do we do about it? And so what we've been thinking about is, how do we reemerge, reinvigorate, re-understand these indigenous systems, and then use that to directly create training programs that use that as the basis as opposed to just the engineering know-how. So we're now trying to think about, can we bridge some of these divides in ways that could be really helpful?
Mm-hmm.
And then the other thing I'm doing now is also thinking about, in that regard, I'm also thinking about how we can use infrastructure as a sensor, as a social sensor. So I really love, so Eric Klinenberg had this really important book called Heat Wave out of Chicago. And he argued that these disasters are like a social autopsy, right? And the idea is that
it was a heat wave that hit Chicago that killed hundreds and hundreds of people. There were trucks out back of hospitals just with bodies in them. Yeah. Mm-hmm.
Right. And basically showed that what this brought into stark relief is a social autopsy of really who's getting left behind when the system is intact and we can't see that. And so what I started thinking about is perhaps, when you think of the word autopsy, it's like postmortem. It's after it happened. I'm like, is there a way we can make this be more like a biopsy, where it's like a test and then you can see it while you can do something about it? And so what we thought about is maybe we can use infrastructure as a sensor in the context of COVID. So COVID is, as we all know, has been a pandemic that's affected our abilities to work. A lot of us have had to work from home, social distancing and the like. And what struck me is I read some recent work from some medical doctors looking at this as it affects African Americans, Blacks, people. And they said that it's really like social distancing is a privilege. Yeah. And I was like, that's interesting. And that's true because some people are in multi-rise buildings. They can't leave. They don't have broadband access. So they got to go to do anything. They're essential workers. And so I said, can we use infrastructure? Could we come up with a unified database? We're bringing in broadband, bridges, wage and economic sector data, COVID data. And we're trying to look at, could we isolate based on pockets of infrastructure where, oh my gosh, this is going to be really where the problem is for COVID. And that's where you should target economic relief, contact tracing, all of this stuff, as opposed to like, where I live, if it's hitting me, I can distance. I mean, that's not as much of an issue. Yeah. On top of that, the reason we got into this is that a lot of the models that are being used right now, predominantly one of them that's more well-known is the one out of University of Washington. And their model, they're assuming astronomically high compliance rates, like 85, 95%. And I said, besides the behavioral issues of whether that's even possible, we're curious, is that even physically possible? If I'm in an infrastructure where I can't move anywhere, I'm right next to someone multi-rise building in a story, how can I even be anywhere near being able to be 6 feet distant?
Yeah.
Sorry, my daughter's here. Hello.
No, man. Nature of the times.
Yeah. Yeah. 1 minute.
I don't know where's the line for spinning.
Oh, you don't know where the line is for spinning? Do you want to? I'll help you look for it later, dear.
Yeah.
All right. Anyway, so basically what we said is like, if you're in a multi-rise building, right, and you can't be 6 feet apart, I mean, you could have the best of intentions, and we know for a lot of these minority communities, because they know it's hitting them the hardest, they're the ones that are more masking than any other people. Right.
Yeah.
And yet, if I'm in a multi-rise building, I don't have much distance. What am I going to do? Right. And so I started to say, like, we need to be more realistic based on the infrastructure. Maybe we can use that as a sensor and realize maybe if we can't hit those compliance rates just because I physically can't.
Yeah.
Maybe I'll target those are the places for economic relief contracts. So now we're trying to like flip it and say, let's make this more of a biopsy than an autopsy. Mm-hmm. Use the infrastructure as a sensor of social life to help us understand how to deal with that. And we think, once we have this unified infrastructure database together, we're hoping to bring in, like, we could look at natural disasters, tornadoes, hurricanes, who are going to be the hardest to find, where are we going to have to target limited emergency relief to find people that are likely, underneath a bunch of debris if it's a tornado, or underneath a lot of water and can't get out. If we can use that to help target these areas. And so that's where trying to take that work, to take these things seriously, this skew, and then use that to our advantage to be more mindful of where we target deployed resources.
That's great, man.
Mm-hmm.
Daniel, I'm just so looking forward to seeing where you take this work. I think it's really super exciting, and I've learned a lot from it so far. So, man, I'm just excited, and I'll be watching.
No, and you've been, I'm telling you, when I started this work, the op-ed you wrote in New York Times, the book you've had was really impactful on me pushing this focus on the old, because that was just when I was starting to get into this space. So you're one of the first that I read, you and Andrew Russell's work. And so I got to say, it's an inspiration, just an honor to be having this chance to talk with you, because you're one of my unsung heroes with regards to this. Honestly, I really enjoyed what you've done. It got me into the space thinking we can do something to help with this. And
Thank you,
I'm
Daniel.
excited to see where you go next as well.
Thanks, man. Thank you so much.
Mm-hmm.